All right, moving on in chapter 2, we're going to be working on larger systems. This one's really fun. So when I say larger systems, what I mean is rather than just working with x and y on a coordinate plane, on a two-dimensional coordinate plane, we're going to be working with x, y, and z on a three-dimensional coordinate plane. So a larger system is just a system of two linear equations that can have, I'm sorry, let me back up. A system of two linear equations can have one solution, no solution, or infinite solution. So remember what that looks like. One solution, no solutions, parallel lines. Infinite solutions means that those lines are right on top of each other. Those situations correspond to intersecting lines. Parallel lines are two equations for the same line. But what happens when you have more equations? What types of situations do they describe? So what I'm talking about is this. When you have three variables, in other words, when you have your x, y, and z, rather than just x and y, your graph has to be three-dimensional. So when you have a three-dimensional graph, you no longer have a line, right? A line is two-dimensional. You now have a plane. A plane is a three-dimensional figure. So with x, y, and z, we're talking about intersecting planes. So let's take a look at an example of what this is going to look like. So think step 1. Can't get rid of that box. There we go. What can you eliminate from this system? So again, this is a larger system with x, y, and z. So we have three equations. Think elimination first for this one. If I look at these two equations, do you notice right away that you can eliminate z? If you add those equations, right away I have just two variables left. So if I add x plus 2y plus z equals 3 and 3x plus y minus z equals 2, I'm going to end up with 4x plus 3y, my z's eliminate, equals 5. All right? So now I've eliminated z, but I haven't eliminated z anywhere else. So I don't have any other equations for just x and y. So what can I do from there? Right, so now we need to eliminate z again. In other words, using a different pair of equations. If we multiply the second equation by 2, let's get that out of the way. If we multiply that second equation by 2 and add it to the third equation, I'm going to be able to get rid of z again, and I'll have another equation with just x and y. So if I multiply this one here, my second equation by 2, I'm going to end up with 6x plus 2y minus 2z equals 4. Remember to multiply every single term. So now if I use that equation with this bottom equation, what happens? 2x plus 3y plus 2z equals 7. Again, if I add those, I'm going to eliminate z again. So now I have 8x plus 5y equals 11. So now I have two equations, the one from up here and the one that we just did, and I'm just left with x and y. So what can I do then with these two equations? Well, here I just have a regular system that we're used to. I'm going to use some multiplication, and I'm going to eliminate again. So now I'm going to have 8x plus 6y equals 10, and 8x plus 5y equals 11. I know you guys like to do negatives, so let me switch that around a little bit. I'm going to multiply that by a negative 2, because I know you guys like to add. So minus 6y equals negative 10. All right, so now, again, these are going to eliminate. I'm going to have a negative 1y equals 1. If I divide both sides by negative 1, I get y equals negative 1. So now I have a value for y. So now we're back to just figuring out our x and y like we were when we were just doing that regular old systems of equations. So now I can substitute that back in and find my x. So I'm going to go ahead and substitute that in whichever one I'd like. The first one seems a little bit easier to me. So I'm going to go 4x plus 3. Again, I'm using this one. 4x plus 3 times negative 1 equals 5. 4x minus 3 equals 5. Add 3 to both sides. 4x equals 8. Divide both sides by 4, and x equals 2. So now that I have my x and my y, you can imagine what we might do then to find my z. So to find my z, I can take any one of those equations and I can plug in or substitute, I should say, my x and my y, and I'm just left with z. So let's just go ahead and maybe use this top one. It doesn't matter which one I use, right? So now I have x is 2, y is -1, so I'm just substituting into that first equation, plus z equals 3. Notice with elimination, really you're just using part of the time. When I say use elimination, you are going to end up using substitution at some point in time. You don't have to use elimination the whole way through. Use elimination as far as you can, then go ahead and use substitution at the end to make it easier. So now I have 2 plus -2 plus z equals 3. At this point, I think you can finish it off, so pause the video and finish this off to find out what z is. So now I have 2 plus -2 is 0, plus z equals 3. In other words, z equals 3. So now to record this solution, I'm recording this as a set of 3 values, right? My x, my y, and my z, not just an x and a y. So there's my plane. There's the intersection of those 3 planes, rather than lines, at 2, -1, and 3. So you can jot these down in your notes. These are just your 4 steps that we just went through. First, we eliminated a variable by using any 2 of the original equations. Any 2. Doesn't matter which one you pick the 2 that are the easiest for elimination. Number 2, you're going to eliminate the same variable by using the unused original equation and reusing one of the others. So in other words, you're going to take a different combination of equations. You're going to eliminate again in order to get 2 equations with x and y. Right? Step 3, you're going to solve the new system of 2 equations that you created in those first 2 steps. So this is just what we've been doing this whole time. You have 2 equations with x and y, and you're going to solve those. Finally, you're going to go back into any one of the original equations, any one of them, to find the value of that 3rd variable. So you have x and y, substitute those back into any one of the equations to find z. Let's look at another method though. So we have elimination, we also have substitution. We can use substitution as well. This is a really good system for substitution because I already have an equation that is solved for one of the variables. It's a really good time to use substitution. So all I need to do at this point is to take what x equals and substitute that into one of my other equations. So let's go ahead and just substitute that into that first equation. So again, I'm just going to take x, and I'm going to put it in place of x in my first equation. So 5y plus 3z plus 3, there's my x, and now I have plus y minus z equals 9. So I'm going to have you pause, go ahead and simplify that as much as you can. So I'm going to compare yours with mine. So I ended with an equation that's in standard form. ax plus by equals c, or in this case, ay plus bz equals c. It doesn't matter the x, y's, and z's, right? This is still in standard form. So I have an equation in standard form with y and z. So next, if I can get to my next. All right, so this is what we just came up with. 6y plus 2z equals 6. Now notice that second equation. So my second equation is 7y plus 7z equals -7. Let's go back a step for a second. I need need that second equation. I haven't done that yet. So I substituted x into the first equation. I'm going to get rid of this mess. But you might have noticed what we didn't do was substitute x into the second equation. So let's do that, because that's going to give us our two equations that both have y and z. So I'm going to go for my next one, 2 times x, and again, x is 5y plus 3z plus 3, and then I have minus 3y plus z equals negative 1. Again, I want you to go ahead and pause and simplify that as much as you can. All right, again, compare your simplified version of this with mine. I have 7y plus 7z equals negative 7. So now I have two equations, both with just two variables. Now that I have two equations with two variables, I can solve that just like I would solve any two-variable system. Now notice with the second equation that we just came up with, if I divide that whole thing by 7, I can solve that for either y or z quite easily. So in other words, if I divide everything by 7, I have y plus z equals negative 1. If I go ahead and continue to solve that, say for y, I have y equals negative 1 minus z. Okay? So now what can I do with that? So y equals negative 1 minus z. Well, now that I have a y, think back to how you've solved systems in the past. I can take that y and I can substitute it into one of my equations in order to find my other variable. So now I have 6 times y, which is negative 1 minus z, plus 2z equals 6. Again, pause and go ahead and solve that for z. All right, so go ahead and check your work with mine. So I got z equals negative 3 by simplifying and solving that equation. So if z equals negative 3, remember, I have this equation that is already solved for y. So I can take that value for z and I can substitute that into this equation. So y equals negative 1 minus what I got here, negative 3. So y equals negative 1 plus 3, and then y equals 2. So now I also have a value for y. So I have z equals negative 3, y equals 2. Now think for a second, if you have two of the variables, I can go back and find that third one using some substitution. So go back, I'm going to use, I've already written it out here, so this is one of my original equations from that original system with all three variables. One of them was already solved for x, so this is a really good one to use to get x. So now I have x equals, I'm going to substitute the two values I've already found. So I found that y was 2, I found that z was negative 3, and then I have plus 3 here at the end. So again, pause and go ahead and solve that for x. One more time, go ahead and check your work with mine, but when I went through and simplified that, solved for x, I got x equals 4. So final step, we want to take all three of our values, y equals 2, z equals negative 3, and then x equals 4, and I want to put those in coordinate form. So now I have x is 4, y is 2, and z is negative 3. So here are your condensed steps for solving a system with three variables by substitution. Solve one equation for one variable, choose the easiest one, substitute the expression from step 1 into the other two equations. Okay, so in this case I had x equals, and I took that and put it in both of the other equations. And in that case, what I did was I found a new system of two equations that only has two variables. I'm going to go ahead and solve that. I'm going to go back to any one of the original equations to find the value of the third.